In this video, we show the practices that support ongoing changes in student thinking. The first of the practices is introducing ideas that students can use to reason with in the upcoming activity. This is an interactive form of direct instruction. The second is engaging students with an activity that generates observations or data. The second practice requires that students use the introduced ideas from the previous practice to reason with. The third practice is using this new knowledge to revise models and explanations for the anchoring event. This set of practices would be used 4 or 5 times throughout the middle of a unit to help students make cumulative sense of activities, investigations, and readings. The ideas that Bethany introduces are carrying capacity and limiting factors. She shares just enough about these so that her students can engage in a data collection activity and use these two concepts as tools to reason with about trends in that data. As always, her students know that the concepts and the investigation will help them figure out the anchoring event. These are not isolated exercises.
What if there were no predators? Could this still, what do you think would happen? Could it still just keep increasing? So turn and talk to somebody next to you, because most of you put predators as the main reason why it couldn't keep increasing forever. So turn and talk to somebody next to you and think, could it keep increasing if there were no predators? Tell us something that they either said or heard their partner say about what would happen even if there were no predators. What would you expect if there was no predators in this situation? Sir?
Well, since there's like 50,000 hares, I'm pretty sure like the food would go down rather quickly, and also there's still the chance of natural disaster happening.
Okay, so what would you expect the graph to look like?
Well, it maybe go up for a while, but then they might start like dying off because there's not enough food around them for them to survive.
Okay. Does anybody want to add on to what Cesar said? Yeah.
I think the graph would go like this, and then like they just keep going like that.
Because
it's like they would die off, and then like they would repopulate and then die off.
And also about the food source can be disease, so the plants around the diseased plant can possibly die.
Okay. And how would that affect it?
That would affect their food supply by being less food for all of them to eat.
Okay, so we have lots of factors. I heard Alan say like there's lots of things to think about here. And so I want to give you a couple of vocabulary words here about this. Okay, and the first one is, you should write this in your notes please, carrying capacity. Carrying capacity is the maximum number of a species that can be supported by the environment. So this is what you were talking about. You were saying you think that it's not, like if I extended this graph here, you don't think that it can keep going up forever because you don't think that the environment can support that many. Yes?
Wait, how would it go like straight up? Because that doesn't, you just can't do that.
Right, so I'm saying you all don't think that that can happen.
No, I'm saying like straight up, like.
Well, it's like a little bit of a...
Oh, I thought like straight up, something like that. You can't have that many
Can't
in
what?
one day.
In one day?
Yes.
Well, what do you think? So it's not an instantly upright line? Okay. But you all said there's like some limit to how much the environment can hold. And so we might expect that it kind of levels off somewhere here. And so you can, on the graph here, there will be a line where you can kind of think of it as the limit of how high the population could rise, and this is called carrying capacity. All right, I want to check if you're understanding this vocabulary term. So what I'd like you to do now is turn and talk to the person next to you and tell each other how you would say the definition of carrying capacity in your own words. All right, so our next vocab word here is limiting factor. All right, so limiting factor is a factor present in an environment that controls the growth, abundance, or distribution of a population of organisms in an ecosystem. So actually, before you write this, copy it down this time, I want you to, let's figure out what it means. So turn and talk to the person next to you and see if you can put this in your own words. What do we mean by limiting factor?
A factor that that makes an organism that's, living. You could tell it how much it can live, by like how many of that organism can live.
Okay. Abundance here, what do we mean by abundance?
How much of something was
How much of something, and then distribution? What do we mean by distribution?
separate?
Yeah, like where they are. Okay. So we'll be thinking a little bit more about these two ideas today. We're actually going to simulate a population and think about some limiting factors that could affect it in its habitat. So we are going to become, well, some of you are going to become deer today. Some of you are going to become the habitat.
Bethany has her students go outside and physically represent a population of deer and also the various resources available to that population. Over repeated segments of this activity, both the resources and the deer population fluctuate. Students record data after each iteration.
Wait, no, we need to know how many. What did you get? All right, choose a card. Yeah. We'll start by just drawing a graph, and then you'll be discussing what this simulation was trying to show, why we had some of these results. I heard some of you talking about it already when we were outside, but now's a chance to discuss that with your table group. You're working with your group that you made your poster with. Because?
Go down.
Because?
Because it can't go up anymore.
Why?
It could go up. That's most of the people are on the deer side, and then there's less people on this side. So like, some people would get those people, and then the rest would have to come back.
So how high do you think it could go? Okay. What do you think about that? Do you agree that it would go down? So what would you guess would be the number on the next round? If you look at your graph. What do you think?
There's more habitat and less deer.
What? What did he say?
So by less habitat.
Okay, because it's going down? Because?
Because of the resources.
Okay. What about him? Not enough? Okay, what do you think? That what?
What was the
Okay.
ratio of
Because?
resources like that?
Okay, so we see an up and down pattern. What did you say?
We thought it'd be like around 10 or around that.
Because?
Because here when it was 15 and it got to 10. So
I think it would be just overall less than 15.
So what would you call 15 then for our population?
The common one?
Okay, so why would that be the carrying capacity?
Because they didn't go over 15, and when it got up to 15, it went down again.
Okay. All right, so then let's think about limiting factors. What would you call the limiting factor in this?
The water, shelter, and food.
What are the limiting factors? Okay, and in this question down here, I'm going to ask you to think a little bit about which one is probably the most likely for. Oh, I didn't like this question very well. I wanted to think about if we were doing our hare population, what do you think would be the most likely limiting factor for our hares?
60,000.
Oh, that would be the. Okay. So you think the carrying capacity is about 60,000? Because.
Do you think the water goes up 60,000 units?
And what would be the most likely limiting factor for our hare population?
Guys, election day, but Berlin.
You can keep thinking about that. I'm just going to write this. I think I was waiting for Ciara to write down.
There's only a few people that was a shelter.
Remember I said that?
I have to have a shelter. That means the predators would be able to get them right.
Didn't have nowhere booze.
Okay, so let's think about All right. So what did you discuss?
Why is it like that?
Okay. And what'd you say?
What you were discussing?
All right.
No, I said that like it can be flat because like the deer population and the resource can be like even out because there's always like deer wanting the resources. And if they like deplete the resource, that makes the thing go down because the deer population decreases.
I know. I'll get it later.
I have a question. Has that ever been a problem? Like, can that actually like be a problem for deer, like food resources?
Like, there's not enough resources?
Yeah, I don't think I've ever heard of that. 'Cause, like, I don't see that much.
Do you guys ever go? You guys ever go hunting?
I heard Martin's.
Yeah.
Bro, I hunt with a spear.
Oh,
Islander.
super. Like a caveman. All right.
Caveman.
So when you're out with your woolly mammoth,
Islander. What are you talking?
what's Islander?
Islander, you know.
I'm not cool. I don't
Boy
know.
Simone.
Oh yeah. All right. There you go. What do you hunt? What do you hunt with spears?
Pigs and deer.
All right. Why?
Because they're hungry. They're big boys.
Big boys need food.
I know, but why are there so many? Why are there so many things you can hunt?
Because they're
Because
hungry.
there's
They got a lot of choices.
No, I know, but why don't you hunt other things
Because they're good.
on the island?
Because I guess that's like the most like precious.
There's the most of them.
Just say a little bit more
Yeah, I
about
guess.
Don't make like hot dogs.
There's a big population of them, so it's
All
easier
right.
to hunt.
Happen in big.
So why is there a big
To give a
population?
chance for the other
Would we maintain a positive
other
Man, you don't care about that.
other animals to give like reproduce, and we start hunting their meat.
So this is really get to Alan's question. Is this a for real thing? Like, what would happen if you guys didn't hunt the pigs? What would happen?
Overpopulated, and they would come into like the city and stuff.
Oh, so
take
like
over,
like the hunters will keep them like
planning
their
of the eggs
population
kind of
balanced.
concept.
Their like population will be balanced because we're hunting them. So like we keep like the
Have you
food
seen like the
chain
movie The Planet of the Apes?
balanced.
So you were talking about that you keep the pigs in check, right?
Keep the
Okay,
pigs-
what island are you from?
Yeah.
What island am I from? From the island of Saipan,
Where's that?
next to Guam.
Okay. Oh, perfect. That's my example. What's happening on Guam?
What's happening?
What's happening on Guam?
You don't know?
I don't know. There's no like.
Not real island.
There's
What's
no-
happening on Guam? You ever heard of some? No, this is a great
My
example. This is exactly what Alan's talking about.
No, like
What's happening on Guam?
we hunt pigs.
Well, you hunt pigs on your island, but what's happening on Guam? Do you know? You ever heard the brown tree snake?
Oh yeah, we do that too.
You hunt?
We kill them
Yeah. Okay. Why?
because they're overpopulated.
Uh huh. And what happened on Guam to all the
They
birds?
killed all the native birds.
Yeah, they sure did. And so why?
Our cocoa bird is extinct because of that brown tree snake.
That's right.
Where's the bacon?
So why didn't the brown tree snake, like, how was it that the brown tree snake was so successful in Guam? And why do you care about killing the brown tree snake so much?
Because they're killing all the wildlife.
Why doesn't anything eat them?
Because there's no natural predator for it.
Do you know this story about the brown tree snake? Richard, tell them the story about the brown tree
Yeah,
snake.
Mr. Islander.
On my island,
On your island.
there was like the brown tree snake originates from like somewhere in Japan or something. Some island.
Kill it before.
And they came in like the shipping because they're shipping from someplace, and they came into the island, started reproducing on the island, and it's overpopulated now. So now they like go inside the houses, bro. They go inside the houses, and they like kill all the birds and stuff.
So what are we saying? What's a general? What's a
Whenever there's a high population, whenever there's a high population of deer, there's always little resources, and whenever there's little, like a small population of deer, there's a lot of resources.
Okay. So one of our hypothesis tests is whether or not that's reasonable or likely. Does that, Ross? Do you think that sounds reasonable?
Oh yeah.
Yeah. What you said. Why do you think it sounds reasonable?
Did Mr. Shinikoff already talk to you about the next point, round 11?
If there's a lot of deer and not that many resources, the deer
So
are
what
going
did
to die.
they
If there's a lot of resources and not that many deer, they're going to be able to eat a lot and reproduce a lot.
So what connects those two? Because those are like two situations, but there's something in between.
Basis, relation of each.
So if we have a lot of deer and few resources, then the deer population goes down, why does the resources go back up?
Because not much deer for the plants eat.
So what about the,
Okay, so there's deer aren't eating the resources.
what do you think is the, how
As
do you
much
think
resources. Okay. And then what happens the opposite? When there's a lot of resources.
your mind is what carrying capacity is?
They're just doing like the same thing, but like other wherever.
So why do you think the population isn't just a straight line? Like, why don't we just get up here and then keep the same number all like on and on and on and on?
Wait, which line are you talking about? This one? The one that's going up and down?
Why is that better? Why do you think that's a better representation than just drawing a straight line all the way
Because
across?
it's more exact. Because the population is more
It shows how like the population decreases and increases.
Okay. And why would a population do that?
because there's... Alright, and then we just repeat about the resources.
Yeah. So what about the resources part?
The more, the higher the population, the less resources there are, which causes it to decrease. And then when there's less of that species, then there's more resources, and it causes it to increase. And then it's just it happens over and over again.
Okay. Do you agree, Kevin? What do you agree about? Okay. And then? Okay.
Well, I think 15 is comparing the carrying capacity because 15 is like the highest it's reached, and then after 15 it just like dropped down. So I think that's like the most it could that environment can support that many of that species.
Do you agree?
I think you think of 13 because after that, like, it gets really scarce. A lot of them die.
Okay. So if you drew a carrying capacity, you put 13 across. So you think 13 is the amount that it could actually support?
Yeah.
Okay. Because
if it was at 15, then it would have handled all at 15.
oh, okay, that's a good thinking. So what do you think now? What? Because why? They convinced you? What did they convince you of?
Because that is true. Like, because like Martin said that 13 is like what it could actually it could actually support all that, because 15 is kind of like on the borderline probably.
Okay, so it kind of like went above it and then it has to do what?
Let's see, what do you want to talk about?
I'm just like, so it went up, it went like above 15 and then what has to happen?
They died.
Okay, so they can't support it.
Yeah.
From the graph perspective. So do you agree, Ciel?
Yeah, I agree.
With which? 13. Okay.
Yeah, what she said.
Because?
What she said.
What'd she say?
So like 13 is like the maximum where they can hold, the higher is 15 is above.
Okay.
Wait, the carrying capacity is a max, right?
12.
The limit, right?
Like right there.
Wait, is the carrying capacity like the limit or maximum?
What did you write down earlier today?
The maximum number of species that can be supported by the environment.
Okay. So Kevin, what do you think is the carrying capacity of this population? Okay, so he thinks 15, you think, what do you think?
12 or 13.
Why?
Because like it's like this one. It's like in the middle. So like, the carrying capacity is right here. So then when the population passes the carrying capacity, it starts decreasing again.
Okay.
Yeah.
So what do you think about that?
I think it's 15 because it says the maximum the environment can have, and the maximum in the graph is 15.
Okay. So what do you think about what she said?
But then if it was a maximum, wouldn't it still be able? So wouldn't it stay the same?
No, the maximum is just.
Why would it decrease if it can still support it?
Because I just can't go higher than 15. Because that's the maximum.
So I think keep arguing your point here.
Like, why would it go down? If it's 15, why does it go down?
So tell
It can still support it, can it? If it's 15, it can still support it.
No, it's the maximum, not minimum.
So
Maximum means it can't go higher than that. That means it can still go down, but it just can't go higher than 15. But if you say it's 12, it went higher than that, and it went to 15. So that means 12 can't be the maximum.
So tell her about the part, because she's focusing on the maximum part. Tell her the part you're focusing on your definition.
Like, so when it passes the carrying capacity, the resources start decreasing, so that means the population starts decreasing. That's why it goes down.
So, but what part of the definition then are you focusing on? Not the maximum, but the maximum what? Oh.
This?
Yeah, so say it, tell her about that. Tell her what you're thinking about.
Just told her.
I'm confused because then when you drew it on the board, you drew it right at the top, and then this one's in the middle of it.
Mm-hmm. So what do you think is a better representation?
I don't know. That's why I'm confused, because I don't know.
Okay. What do you think, Kevin? What?
I think the other one, because you said maximum.
Okay. All right, so I think what Moses is trying to argue here is that the definition he wrote down is it's the number that can be supported by the environment. So he's saying, like, you get to 15, and then 15 actually can't be supported by the environment because...
And how come on that one you drew it on the top?
So I drew, like, what you would maybe think of the carrying capacity as being, like, the maximum amount you could have. But if we look at this model, what does it show?
Up and down, or increases and decreases.
And like how does it increase and decrease with relation to the actual carrying capacity? Go ahead.
Like, passes it goes over. It goes over the carrying capacity, then it goes under and over again.
So that one is just for if it were to just level out.
But so like the carrying capacity I think of as like this level that is how much it could support. But like as you were saying, it sometimes goes past it, but then what happens? It goes down because it can't support it. So when we try to think of a carrying capacity, we're going to think about how many could be supported. So maybe you could draw that on your graph. Or you think and so as I came around, I asked you and your group to think about what would you say is the carrying capacity of this population. So, and I heard a couple of different answers. And is that what you're representing here, Wallace?
Yeah, that's okay.
Okay, so he puts this as a carrying capacity, and he said it was because
Because that's the most that was there.
Okay. So kind of was like the population cap. And so as I talked to some other people, I heard some other ideas about this. And so probably about half of you thought about this being kind of the cap, the carrying capacity. You kind of take that cap part of capacity and say it's the top. Okay? But some of you have some different ideas about carrying capacity of this population. So could I hear from somebody what you think? Go ahead.
Like at first I thought it was 15 too, but then like Martin was talking about how he thinks it's 13 because like that's how much the environment can actually support, and like 15 is kind of like on the borderline, and yeah.
Okay. Yeah.
And if the capacity was up to 15, then it wouldn't decrease at all because it was able to handle all 15
Okay.
throughout the years.
Some people didn't believe it was 15 because even though we did reach 15, we weren't able to support it, so it went straight downwards after we reached 15.
The capacity is like 13 because that's all the environment can support. And if they go to 15, the population is going to decrease.
Okay.
First of all, there's like 3 points at 12. So if you like could make a line that would go up to 12 and then like even out, you can see that that would be the, what's it called? Constant, wait, no. Capacity, that would be the capacity, right? And anything like way over, way under, or outliers, or they're overshoots, you know, because of, you know, things that could happen. Like maybe there's a drought, maybe that could happen, I don't know, something, right? So those are just like random, but it should always be around 12 or 13, because that's
above or below? Do we agree with that? I see a head shaking. Bass, you don't think it's random? What? You don't know? But your instinct was like, no, it's not random. Okay, so I'm just curious, what do you think about that? What causes it to go above or below that carrying capacity line?
The limiting factors.
Okay, say a little bit more about that.
There's not enough of one factor to support all the animals, such as deer. So if there's not enough, they'd all go down, like the population will go down, or not enough for all of them. And if there's a lot, there's an overabundance of it, then it would go up like to 15.
Okay. And so we see that sometimes you get like this burst above it, but then once you get above it, then it can't be supported, so it goes back down. All right, so what I'd like to do now is think about how this relates to our big question we have about the hare population. Okay, and so we're going to take a few minutes here to think about how it relates. In your journal, you need one big page, or maybe open your journal sideways, and make these columns, please. But we're going to keep track of these things that we do, and also think about how they're supporting your hypothesis and how they're supporting other hypotheses in the room. And so we're going to fill the first one in together. So in the first column, we're going to just say that what the activity was, kind of to remind us maybe the name of the activity or the main.
Deer versus wild.
Deer versus wild, okay. Simulation or whatever you said. So just something to remind you what the name of the activity is. What you write down does not need to be an exact copy of what's on the board. This name is to remind you what we did. So you could even call it just deer thing on tennis courts, okay?
Small game.
Deer game, yeah. Whatever you want to put to remind you the name of this, like what this activity is.
And we just like summarize it?
Yeah, so that's what we're going to do next under what happened. So what did we see, or what was the result of what we did? So in this column, we're going to summarize what happened. In this chart, we're going to explain why, and so we'll start thinking about like the actual reasons behind it. So what could you put in this column to kind of remind yourself what happened? What do you think you might put there? You could use words or drawings. You might choose to draw a little quick sketch of the graph that we just had to remind you what happened. So you might draw what we saw, just something like, I don't remember, but something like that. Okay, so I want to just write down what happened. What were the results of this activity? You don't need to explain why yet, just say what happened. What is this graph even showing? What do we see on the graph? So could somebody please summarize for me, what is our graph that we had shown, the one I showed you of Wallace's graph? What did it?
The more resources equals more deer.
Okay. Do you think that's kind of like why the graph was showing it, or just what we see on the graph? That's a why. Okay, so let's start with just describing what the graph shows. What do we see? The deer population increases and decreases. Or goes up and down. Okay. For homework, write this down please somewhere where you're going to remember what your homework is. I want you to try to fill in the Y column, and we'll talk about it. Actually, you don't have to write it in the column yet. Maybe write it somewhere in like scratch paper, and we'll talk about what we can put in the Y. Why did this happen? Why did the graph go up and down? Abbas already gave you a little bit of a hint about what he's going to put in the Y column.